So in this video, we're going to cover right triangle trigonometry. Now, this is something very useful, you use it from geometry all the way down to calculus, and it comes in really good use in pretty much all of mathematics. So let's get started. Now, by the end of this video, hopefully you're going to be able to apply the three trig ratios, and you'll no longer refer to them on your calculator as sin, cos, and tan. So let's get started. Let's do tangent first. So tan of some angle theta is going to be equal to our opposite side over our adjacent side. Let's do sine. Our sine ratio of some given angle is equal to our opposite side over our hypotenuse. And lastly, our cosine ratio is equal to our adjacent over our hypotenuse. Now you might be thinking this is a lot to memorize, but we have a little tool we can use to help us remember this. So let's write that down. And that is SOHCAHTOA. So whenever you have any kind of right triangle trig problem, I recommend that you always write this down, because it saves you from making a careless error, and you don't want to wind up using the wrong ratio and then getting a wrong answer. So as you see, you think of sine equals our opposite over hypotenuse, and then ca would be cosine equals adjacent over hypotenuse, and toa being our tangent, which equals opposite over adjacent. So we can see how that comes in really good use. So let's try an example now. So let's do, let me draw a right triangle as best as possible. Okay. So let's say we're given an angle, let's do 35 degrees. And we want to find this side right here, and let's say we're given 6 right over here. So let's think about it a little bit. What ratio fits this scenario? The hypotenuse is irrelevant right now because it's just blank. So we want to work with our opposite and our adjacent. So which of the ratios involves those two things? I'm thinking tangent. So let's try it out. So our tan of 35 is equal to our opposite side, which is our unknown, our x, over adjacent, which is 6 in this case. So then it's just algebraic, so let's isolate x. 6 times our tan of 35 equals our x. Now this would be our exact answer, but typically they want an approximation, so let's just average that out. I'll just type that in my calculator quickly. So 6 times the tangent of 35, and that averages out to 4.2, and that makes sense when we think about it. So why don't we do one more, and then I think you'll get the idea. So let's say we have another right triangle. A little different. You know what, let me redo that. Let me do something a little bigger. Let's do this. Close enough. So let's say this angle here is 46 degrees. And let's say they give us 10, and we want to find this right over here, our adjacent side. Oh, and one thing to note, the hypotenuse is not an adjacent side. I've seen people make that error and it's not good. So don't do that. The hypotenuse is the hypotenuse, not an adjacent side. Only the legs can be adjacent sides. So let's move forward. Now in this problem we want to work with our hypotenuse and our adjacent. So which of the ratios involves those two things? I'm thinking cosine. So let's go ahead and do this one out. So our cosine of 46 equals our adjacent, once again our unknown, over 10. So we're just going to do the same thing as the previous example, 10 times cosine of 46 equals x. Let's approximate. Use my calculator once more. Cosine of 46, that comes out to be 6.9, which makes sense. So I think that would be sufficient, and you get the idea. So remember, always write this down, SOHCAHTOA, on every test or quiz or whatever. If you're just doing homework, it helps. It saves you from making careless errors, and I hope that helps.